Welcome to Notes 2.5, Word Problems with Scientific Notation. This is for Math 8. The goal of this video is to work with scientific notation in word problems. So now that we know how to add, subtract, multiply, and divide with scientific notation, we need to learn how to be able to apply those to word problems. And just so you know, the majority of your unit test will be on this. So let's get started. What I want you to do whenever you have a word problem is I want you to go through and I want you to underline any of the important information. So let's find the important information in number 1. It says the outer wall of a large tourist attraction in Cambodia is about 1.1 times 10 to the third meters long and 8.1 times 10 to the second meters wide. Find the approximate area enclosed by the wall. Let's circle area because we are looking for area in this question. So let's pretend that we have, 2 meters here, and let's pretend that we have 5 meters down here. Okay, so if you were to find the area, what you're going to do is you're going to multiply the length times the width, and so we would multiply 2 times 5 and we would get 10. Okay, and so what I want to do right here is I want to actually write down that the operation is multiplication. Okay, so we are going to be multiplying our numbers together. Unfortunately, though, we don't have 2 meters and 5 meters. What we have are scientific notation. We actually have the 1.1 times 10 to the third, and we have 8.1 times 10 to the second. And so what we'll do here is we're going to multiply these numbers together. So let's start off with the formula for area. Area equals length times width. That's a cursive lowercase l. That means the area in this case is the length, 1.1 times 10 to the third. And that's your meters for length, and that's going to be multiplied by 8.1 times 10 to the second. So all I've done is I've taken my dimensions for length, substituted that in for L, and for width, substituted that in for W. What I would need to do now is to apply what we know about multiplication in scientific notation, and in this case we know multiplication does not require equal exponents. So what I would have is the coefficients multiplied together, 1.1 times 8.1, and the result or product of that will be multiplied by 10 to the third times 10 to the second. We will add the exponents there. That will be 10 to the 3 plus 2. Okay. What we need to do is, at this point, simplify that exponent, 10 to the fifth. Off to the side here, let's multiply 1.1 times 8.1. What we have is 1 times 1 is 1. 1 times 1 is 1. Let's carry the 0 down for a placeholder. 8 times 1 is 8. 8 times 1 is 8. Add columns. 1 plus 0 is 1. 1 plus 8 is 9, and 8, with nothing there to add, is 8. 2 decimal places should be accounted for down here, 8.91, and so what that will give us is 8.91 times 10 to the fifth. The good news here is the coefficient is between 1 and 10, and so I know that this is written in proper scientific notation, and make sure that we put our units on here. So 8.91 times 10 to the fifth meters squared. So make sure that you know that it is units squared because we're finding area. Now let's move on to number 2. If we scroll down to number 2, it says the planet Mercury has an approximate mass of 3.3 times 10 to the 23rd kilograms. So what we'll do, we'll make sure we underline that key information. Mars has a mass of about 6.4 times 10 to the 23rd kilograms. How many times as great as the mass of Mercury is the mass of Mars? Round the coefficient to the nearest tenth. So again, how many times as great as the mass of Mercury, and then make sure that we round to the nearest tenth. Well, with any scientific notation word problem, what we need to do first after we underline our information is to figure out the operation we're using. And so what I'm going to do, I'll write operation. Now let's get to it and figure out what we are using here. So what we're looking at here is the phrase, how many times as great as the mass of Mercury is the mass of Mars? How many times as great? So what we're looking here is at Mars. Mars must be the bigger one, and Mercury must be the smaller one. So let's try to work with some numbers that are easier than scientific notation. So in this case, I said Mars is the bigger one, so let's make that 30. And let's go with Mercury. Let's make Mercury 5. Okay, well, if I want to figure out how many times bigger 30 is than 5, what I would do is I would say 30 divided by 5, because that will help me figure out what I multiplied 5 by to get 30. Okay, so 30 divided by 5. So what we have here must be a division question. And this phrase is really, really common. Whenever we see how many times as great as something, we should know automatically it'll be division. So back to the context of the question, we're not actually using 30, we're not using 5, so I'm going to get rid of these numbers here. I want to really focus back on the phrasing. Let's see, if I wasn't understanding what this phrase means, I guess I could figure out the biggest number or the bigger number by looking at the size of the exponent. The bigger the exponent in scientific notation, the bigger the number. Well, they both have equal exponents, and so then what I have to do is I have to look at the coefficient. If equal exponents and you're comparing numbers in scientific notation, then resort to the coefficient. So that must mean 6.4 times 10 to the 23rd is the bigger number. Okay, so again, this is a division question. Let's set this up as a division question then. 6.4 times 10 to the 23rd divided by 3.3 times 10 to the 23rd. So let's do the division. 6.4 divided by 3.3 is really asking how many times does 3.3 go into 6.4? Well, because I have a decimal out front here, what I need to do is I need to move the decimal over. Since I've moved it over one time, let's move the decimal over one time there. And so what we have is actually 33. How many times does 33 go into 64? Okay, so 33 won't go into 6. It will go into 64. How many times? One time. So 1 times 3 is 3. 1 times 3 is 3. When I do the subtraction here, 4 minus 3 is 1. 6 minus 3 is 3. Now 33 will not go into 31. But if I bring down, and I'll put my decimal place there, if I bring down a 0, 33 will go into 310. How many times will it go in there? I believe it goes in there 9 times. So 9 times 3 is 27. 9 times 3 is 27. Add the 2, 28 and 29. Let's do our subtraction here. 0 minus 7 can't do it. Let's borrow. 3 goes 2. And bring a 10 over here. We got 10 minus 7 is 3. Let's see. That should be a 10 as well. 10 minus 9 is 1. And 2 minus 2 is 0. 13. Let's see. Okay, well, will 33 go into 13? No, but it will go into 130. How many times will that happen? 33 goes into 130 3 times. And 3 times 3 is 9. 3 times 3 is 9. Let's make sure we subtract this. Let's borrow here. We get a 2. 10 minus 9 is 1. 2 minus 9, can't do it. 0. 12 minus 9 is 3. It looks like it's going to continue on. Another 0. You'd bring that down. You have 310. Okay, at this point, though, I don't need to go any further because the question's asking nearest tenth. And so that is going to be approximately 1.9. All right, so what I would do is I would say my answer is approximately 1.9 times 10 to the 23 minus 23, or 10 to the 0 power. And we know that anything to the 0 power is 1, and so our answer is approximately 1.9 times as great. And so again, our answer is approximately 1.9 times bigger. Okay, what I want you to do is to make an addition here to question 3. I want you to add in the area of the Pacific Ocean is 6.4 times 10 to the 7th square miles. That's a big number because 7 is the exponent. When compared to the area of the Arctic Ocean, is not as big. The exponent is 4 here. It's about 5.4 times 10 to the 4th square miles. Again, when comparing scientific notation numbers, the bigger exponent indicates the bigger number. So in this question, our important information is 6.4 times 10 to the 7th square miles and 5.4 times 10 to the 4th square miles. What we need to do is to look in question A where it says the sum. Now in this question we should know that sum indicates addition, and so our operation here is addition. We don't need to go through and use numbers like we were in the previous question because it really tells us right off the bat what to do, and that is to add. So we have 6.4 times 10 to the 7th. That will be added to 5.4 times 10 to the 4th. What we should notice here is we are adding in scientific notation and we don't have equal exponents. What we should do is we should make the exponents equal. I would suggest we make the smaller exponent larger so that it matches the 7 in this case. And if you remember from class, I'm moving the smaller exponent up so that it lessens the chance that we have to adjust our coefficient in the end. So I want the 10 to the 4th to become a 10 to the 7th so that the exponents will match, but because I am changing 10 to the 4th into a 10 to the 7th, I need to account for that. So I would also need to say times 10 to some number. Well, that number must be -3 because -3 plus 7 gives me 4. It's still multiplied by 5.4. And this is addition, and I'm going to bring down the 6.4 times 10 to the 7th. That first number is not going to be changed at all. Okay, at this point what I would need to do is to bring down the 10 to the 7th, and we're going to say treat this 5.4 times 10 to the -3rd as something that needs to be changed into standard form. 5.4 is multiplied by a negative exponent. We know that will make 5.4 smaller. How many places smaller? Well, it must be 3 because the exponent is 3. So 1, 2, 3. That must mean we're going to add 2 zeros. So we will get 0.0054. Okay, put my parentheses here. And its addition, 6.4 times 10 to the 7th, again gets brought down. Nothing to do there because I did not need to change the exponents. Okay, well at this point what we need to do is we need to say 6.4 added to 0.0054, and that will be multiplied by 10 to the 7th. Okay, again when you're adding you want to make sure you line up your decimals. So 6.4 and 0.0054, add those together, and what we will have is some placeholders here, 4, 5, 0, 4, and 6. And so it looks like our answer here is going to be 6.4054 times 10 to the 7th. I believe that is in correct scientific notation because the coefficient is greater than 1 but less than 10. Greater than or equal to 1 but less than 10. So real quick, let's talk about something that just happened in this question. Looking at the exponents, I would have thought that when I add these together that the exponent would have changed and got, well, I thought this number would be a lot bigger. 6.4 times 10 to the 7th, that's a very, very big number. 5.4 times 10 to the 4th is still a very, very big number. But 6.4 compared to my answer, 6.4054, I just feel like it should have been a lot bigger when I add these two together. Well, I wonder why it's not so much bigger, at least that it doesn't appear so much bigger. The reason is the difference between the exponents. Okay, 5.4 times 10 to the 4th is still a really big number. Okay, but it's not nearly as big as the Pacific Ocean's area because it is times 10 to the 7th. It is such a bigger number than the Arctic Ocean, and that is the reason that the coefficient doesn't seem to actually get that much larger. It's just that we have a much larger number here, the Pacific Ocean, just due to the exponent. But with that in mind, question B says, how much larger is the area of the Pacific Ocean than the area of the Arctic Ocean? So if we're going to answer question B, what we need to do first of all is we need to figure out what is the question asking us to do. It says, how much larger? How much larger? Well, in order to figure out the operation we would use, let's use some easier numbers to work with. So if the area of the Pacific Ocean, let's say that was 10. So if that were 10, and the area of the Arctic Ocean, let's say that's 7. Well, how do we figure out how much larger one is than the other? I think we would have to subtract 7 from 10, and that would give us how much larger one is than the other. And so it looks like our operation that we're going to use here is subtraction. So let's actually set this up. What I'm going to have here is the area of the Pacific, which is 6.4. 6.4 times 10 to the 7th. And we will be subtracting the area of the Arctic, which is 5.4 times 10 to the 4th. Since this is a subtraction question, we need to make sure that the exponents are equal, otherwise we cannot subtract. And so what I'm going to do is I'm going to choose 4. I'm going to make 10 to the 4th match the 7th by changing it into 10 to the 7 and account for the difference between the 4 and the 7 by multiplying this by 10 to the, must be a -3, because -3 plus 7 is 4, right? And this is multiplied by 5.4. So again, I'm forcing my exponents here to be equal. I'm going to bring down the 6.4 times 10 to the 7th. Now, at this point, I do have a 10 to the 7th in both numbers. What I want to do then is bring down 10 to the 7th. And let's convert 5.4 times 10 to the -3rd into standard form. If I multiply by a negative exponent, my coefficient will get smaller. By how many places? Well, -3 is my exponent, so it must be 1, 2, 3 places. And so let's add zeros in as placeholders, and so it must be 0.0054 times 10 to the 7th. Okay? And again, that is going to be subtracted from 6.4 times 10 to the 7th. So we're almost there. What we need to do is the actual subtraction, and so we're going to go through and line up our decimals off to the side. 6.4 minus 0.0054, and make sure that we have placeholders here. Okay, we're going to be subtracting from 0, so we'll need to do some borrowing. Okay, so in order to be able to do this, let's borrow. There's a 9, borrow again, there's a 9, the 4 will turn into a 3. Now we have 10 over here. 10 minus 4 is 6, 9 minus 5 is 4, 9 minus 0 is 9, 3 minus 0 is 3, my decimal point, and 6 minus 0 is 6. So what we have is 6.3946 times 10 to the 7th power, and our units were miles. So we were dealing with area here, so it's 6.3946 times 10 to the 7th square miles. And it looks like our coefficient is the right size, between 1 and 10, and so there is our answer. We won't be doing question 4 in this note. Please skip that. Stay tuned for the question at the end of this video, and I will see you next time in class.